Hello, my friend, and welcome in this new recording. Today, we continue with another DevLog session on the NervLand project. So, we are reaching the DevLog number 25 already. And this one is going to be about the IMGUI integration into our engine here. So, yeah, let's just get right into it already. First thing I need to mention is a small tip actually concerning the usage that you can make on GitHub, because on my side I actually already had a fork of the main repository for IMGUI. So this is the main repository you have for this project. But when I made a fork initially, I was only forking the master branch, which is a perfectly good branch. You can use that directly, but there's also a different branch in this project, which is the docking branch, which is maintained in parallel to the master branch, and which is providing the new docking and multi-viewport feature. So I really wanted to have a try with this one, except that on GitHub, if you already have a fork for a given repository, you cannot make another fork for a different branch. So since I only had the master branch, yeah, I was stuck with that one. So there would be a few different options to work around this problem. The path I took myself was to simply delete the fork that I had for this repository to be able to make a new one. How would you do that? I don't think I can. I'm not even connected here on GitHub, so I need to connect first if I want to show you that. Wait a sec. Actually, no, I don't even need to connect because this is what I have already provided here in the corresponding article. What you would need to do would be to go on your own repository for the project on the settings tab. Then you would navigate down on this page and you would reach this danger zone, and from there you can actually delete this repository. That's actually what I did. And then you can create a new fork of the official repository if you want. And when you do that, you need to ensure that this checkbox here is not ticked. So by default, it would be checked. So you really need to uncheck this one. And yeah, that's all you need, in fact, to get a full copy of the official repository with all the branches. So this is what I did, and I got the master and the docking and all the other branches also. So that's one way to work around this limitation. Another way that I see, but I didn't try it, would be to keep your existing repository. So imagine in this case, I had the IMGUI repository, but only the master branch on my side. So you could keep that, but then you would check out this repository on one of your computer, and you would need to add a new remote to the Git checkout that you have on your computer. So typically you would have a single remote that would be your origin, which is the default remote pointing to your own repository, but you could also add the official one as another remote. And from that point, you could check out the docking branch from the official remote into your local repository checkout. And at that point, you could either decide to just keep it on your local computer if you need to work with that branch, or you could even push this branch back on the origin remote, which is your own version of this repository on GitHub. So then on your origin, you would have the master and the docking branch. So in theory, this should work. You can do that either with different Git commands from the command line directly. That would be something like git remote add something. I'm not quite sure. I don't really remember those commands by heart. Another way to do it, I think, would be with Visual Studio Code. Let me just try that. For instance, if I go on one of my projects here, for instance, NervProj, and you go on the Git tab, and yeah, you could do something like remote, add remote, something like that. That would work. Then you would provide repository URL. Okay. So yeah, that's where you would provide the corresponding URL. Probably you would provide a name for your remote after that, and that would be added to your own local checkout here. Another way to do it would be to manually add this change. So let's say, for instance, I go again into this NervProj project. You have the Git folder here, and in there you have your config file for Git. Can I open that already with yes, I can. So typically you could just come here and you would do something like duplicate this path and call that like whatever. That would be official or something. And then you would change the location that you have here. Do something different, of course. And I don't think for the fetch, this is interesting. I'm wondering, fetch remote. Yeah, you probably need to change this name also to be the same thing as the remote name that you're providing here. So again, I think I've tried that somewhere already, manipulating this file and adding myself a remote manually, but in this case, let's not try to modify this. You will have to kind of investigate. Okay, so this was before I could start anything on IMGUI. But then, yeah, I just made a copy of that locally. And the basic idea with this project is that you need to take the sources from IMGUI and kind of integrate that into your own project. There is, in fact, no build file or anything like that. If you look at the content of the official repository here, you have a bunch of CPP and header files, but there's no CMake or make or configure or anything like that. MISC, what is this in MISC? Yeah, more source files, I guess. Not necessarily needed, maybe. Documentation is documentation, and that's all you have. So you really need to take those source files and put them into your actual project. So this is what I did myself. So I have a screen copy here. Come on. Taking all those files. All those one are from the root folder of the repository, and then you see those here, which are implementation SDL2, implementation WGPU, WebGPU. Those you will find them in the backend folder. So you really need to have all those main files, and then they hit this concept of backend for IMGUI, which means that you can integrate that into different kind of environment if you want in your project. So you could have a project which is using SDL2, another one which is using GLFW, and that would be what is called the platform backend, and I mean the windowing backend mostly, I guess. And that's one side of it. The other side is you need a renderer backend, and for the renderer you have the choice between DirectX, OpenGL, Vulkan, Metal, and also WebGPU now. So if you go into this backends folder, you will find all of those different implementations. So DirectX 10, 11. This is for the windowing management with GLFW or GLUT, or as I said, SDL2. There's even SDL3, which is not yet released, I think. And yeah, you have quite a few different options, and you don't need all of this. You actually need only one windowing backend and one renderer backend to get your system on Rails. So it depends on what you have in your own project. Concerning documentation about all that, I'm not sure where I actually started myself. Let me see. These are more examples of everything. I think it's in the backend folder, or maybe in docs. Docs backends. Yeah, so that would be a good starting point with indication of what you should do depending on what you're using and what combination are working. I guess actually all of the combination are working. I'm not sure about that, so you need to check. So what are backend and so on. So I kind of never view of this one, I remember, but yeah, what you can also have a look at then are the examples, which are giving you working examples of different combinations of a given windowing backend and a given renderer backend. So for instance, this one would be GLFW with OpenGL2. And in fact, the one I have been using myself is this one. For the unscripted situation where you would like to build an application as a WebAssembly package to deliver that in the web browser. So you have a dedicated example of that, which is absolutely great. And this is the one I've been using. So let's see. Yeah, that's kind of what I'm mentioning here. And from this one, you will see that you could use GLFW or SDL2 when you are targeting unscripted, as far as I remember, or maybe also even SDL3. I think I've seen something like that, but well, whatever. For my part, I am using SDL2 anyway, be it in the web browser with unscripted or also in the desktop application that I'm building. So most of the time I want to stick to SDL2, and so I started with this template, but I have been replacing everything concerning GLFW by the SDL2 backend, obviously. Let's see what I mentioned about that. Maybe it's time to have a look at the actual test implementation that I provided. So this was built like another of my WebGPU test application. So as usual, you will see this setup app function. Everything is integrated into this SDL app context. And here we start with a regular minimal setup where I build a camera, I build a skybox, and I'm just doing a textured cube in the center of the scene, and I can just rotate around this scene. So from this part is business as usual. But then we have this part where we start actually setting up the support for IMGUI. So this, I think we should find already exactly the same thing in the example file here. So you would start by initializing, well, first you start with initializing the windowing framework So that would be SDL2 as I say for me, but this part is integrated into this SDL app context parent class, so I don't really need to deal with that anymore. Then you add in this case this init WebGPU function, and if you look at this one, it's really trying to use unscripted to retrieve this WebGPU device and preparing the surface from the device and the HTML canvas. Yes, that's it. That's again not something I need to deal with in the current version of my application, because I'm really only targeting the desktop version of WebGPU. But eventually, in fact, I could get back to this kind of code, and because when I need to move to actual WebAssembly compilation, I would need something like that, I presume. But anyway, not really useful for now, so I just disregarded this part. And then you move to this part where you start initializing IMGUI, creating a context, setting up this I/O component, which seemed to be an important part in this framework. So that's where you define that you want to enable the keyboard and gamepad and so on. What else? You define the style, default display style. Just kept that to black also. And yeah, this one was an interesting part, because in the GLFW implementation files, you have this init for other function call that you can use in the case of WebGPU initialization. But if we look in fact at what we have for SDL, so let me get back to the way back in SDL2. So you see that for this one you can init for OpenGL, Vulkan, DirectX, Metal, or even the SDL renderer, but there's no for other or for WebGPU. So when I first seen that, I was a bit worried and was wondering, okay, how will you do it then to init for WebGPU? But in fact, if you just go at in the corresponding function, is it working if I just control click? Not quite. Oh yes, it is. Yes, at the proper location. If you just go into those functions, you would see that, okay, you start with a simple function pointer, and you really call a pretty standard function, which is this SDL2 init with the window, no renderer, and no GL context in this case. Same thing for Metal, just a window, no renderer, and no GL context. So from there, I assumed that, okay, maybe the WebGPU backend was kind of similar to those two, and you don't really need to provide anything special. And yes, that's true. You can in fact just, I think I'm using this one in it for D3D. So let's see in the code, setting up the style, yeah, in it for D3D, and just providing the SDL window pointer, and this is working just great. So you don't need to do anything special for WebGPU. Next, you need this one, which is the initialization of the renderer itself, the WebGPU renderer. For this one, you need to provide the WebGPU device, which I can retrieve from my engine pointer, the number of frames in flight. That's another interesting concept, because normally when you use WebGPU or even Vulkan or DirectX 12 and so on, you have this concept that you can basically process frames from multiple threads and in parallel. So you could be processing frame number 1, but also at the same time start the processing for the next frame number 2, and even just slightly after that start the processing for frame number 3 before you're done with processing completely frame number one. So you can have multiple frames being processed in parallel, and that's actually what is considered to be the number of frames in flight. I mean, as far as I understand. And yeah, when it comes to Vulkan, this is a bit of a tricky concept because you have very tricky considerations to make on what you can do with a given command buffer. If the command buffer was for frame number one, for instance, and frame number one is not completed yet, you cannot just reuse this buffer because it's still considered to be locked or in use if you want. And so you need to have different buffers, figure out when you're done with the frame number one, when you can reuse a given buffer, the command buffer, and so on. Pretty tricky. But in the case of WebGPU, I think all this has been simplified. But to be honest, I'm not completely sure about that because so far I haven't really touched this multi-threading aspect of things. I'm just processing frames one by one on a single thread. So starting very simply, but maybe at some point I hope to get to multi-threading processing. And meanwhile, it doesn't seem to hurt to specify that you want to have 3 frames here in flight. So I just kept that as a default value, which is also what you have in fact in the example, as you see here, 3 frames in flight. After that, you can, for instance, try to load additional font file, but for now I just disabled that because I don't really need it to test this part. But it's good to know that it's that easy to add additional font files. So also something I would want to introduce at some point. And this is it for the initialization. Then you get to the actual rendering itself. And for the rendering, which is here in the main loop step, you see that there is one part already, which is actually rebuilding your WebGPU objects whenever there is a change in the swap chain dimensions. So you see that you keep track of the WebGPU swap chain, which and height, and if what you're currently reading is different, what you do is you invalidate your previous object, you rebuild the complete swap chain, and after that you recreate your device objects in your WebGPU renderer. So this is done only when there is a change detected in the size for your swap chain. So on my side, where do I handle that? Let me see. So this is the part where I disable the font loading. And yeah, I'm using a bit of special processing here. We'll get back to this one, but for my part, the rendering is done here in this render frame, and that's where I would check if there's a change in the swap chain dimensions. And in this case, I just consider that I need to update this the IMGUI object, and I just call those 2 functions for now, validating the previous objects and creating new objects. Thing is, currently I do not support resizing the swap chain at all once it's created. So this is something I need to look into. So probably what I will do next. But for now, if I try to resize the swap chain, it's going to be a problem. I mean, in fact, it's only a problem if you're reducing the size of your window, because then the viewport which is used by IMGUI is bigger than your window, and WebGPU doesn't accept that. But it's not a problem, in fact, if you grow the window, because then the viewport used by IMGUI is smaller than your actual full window size, and that is not a problem. But then you get distorted effect when you move the cursor around, so not good anyway. You really need to rebuild the objects. Anyway, so that's it for setting up those objects. And then the main part is this: how you would actually generate a new frame for IMGUI. You process your display as usual, and then you request those new frame. You call those new frame. Three different function calls, but okay, that's it. That's how it is. And we have the same thing in this case. You start a new frame, and then that's where you do the IMGUI main thing, which is building the actual GUI you want to display. For the simple implementation that I did for now, I just provided this one showing the demo window, which is actually already very big and very complete, because this is the official window displaying everything you can do. I mean, probably most of the thing you can do with IMGUI. So very cool to have this just out of the box. And but you could add more windows like shown here, and when you're done defining all those windows, you would call this function to do the rendering itself internally for IMGUI, but not actually displaying anything. It's just preparing what is called the render data for IMGUI. And in the case of WebGPU, then you need to use this render data to populate render path encoder. So as you can see here, you would build everything for preparing a render path encoder, and that's a function you would call to collect all the data that you have rendered just before and send that to your render path to actually get something to display on top of the previous render path for this frame. And that's basically all what you do in this render path. You call this function and then you finish the render path. And yeah, you also need to kind of push this render path in the on the device queue for rendering. Point is, on my side, I already have a pretty advanced concept on how to deal with those render passes, and that's why, in fact, I am not really building a new render pass here in the render frame, and because you would need to build to build that manually in my case, but I can do that directly in the setup function, and this is what I'm doing here. I'm doing the preparation of the first render pass, where I build my skybox and I draw my simple object, and then I'm adding an additional render pass, which is defined here, and this one will be rendered on top of the previous one. And when it comes to actually recording data for this render pass, I get the path encoder as an argument, and I can just call that the same function as before, and it's going to retrieve the data that was previously computed. So the logic is, you get to this function, you execute all of this, you start a new frame, you display your demo window, you do the rendering, and then when it comes to executing the render pass here, when you reach the render pass number 1, this function here will be called when it comes to encoding this render pass number 1. So it's the same thing as what we have in the example code here, with this function called after the render. And yeah, that's it basically. Another thing I added then, I think this is something I'm mentioning later in the article, so let's have a look. So let's just figure out where we are exactly. I mentioned this render pass, dedicated render pass. I had a few issues at first because I was mixing the texture formats when it comes to initializing WebGPU. This was incorrect. This also was incorrect at first, but when I'm fixing those two, I could get something like that to display. So I had some kind of GUI, but on the black screen, and I could not really interact with that GUI. And yeah, took me a bit of time to figure this out, but that's because you also need to process the events that you're receiving from SDL and send that to IMGUI. So that's why I introduced this additional handler. So this is what I'm defining just after here. I retrieve my window manager, and I had a dedicated handler which is going to request to process the event with the SDL2 implementation. And next you have an additional step, which is whenever you're dragging the GUI window, for instance, you don't want to rotate the camera around your scene object at the same time. So you have this concept of the GUI currently using either the mouse or the keyboard. So all the in this case, all the events should not be forwarded to your main processing system if you want. So this is what I have here. So when I return true, it means that the event should be considered as already handled, and you don't want to keep processing it with your additional handlers in your loop. And yep, I think that's most of it. After that, I could get the window to, I could move that window, could interact with the buttons, the slider, and everything. So that was great. The only issue remaining was the fact that everything was on a black screen, but this was a dummy mistake from my side, because when I'm rendering the second render pass, I also need to ensure that I'm keeping the output and the image data generated from the first render pass. And it wasn't the case at first. I was clearing the color with a black clear color. So you definitely don't want to do that if you're using multiple render passes. And just changing this was enough to fix this issue and get everything on rails. So yeah, I actually fixed that afterwards. After that, I also tried adding support for the docking feature in IMGUI, which is what we have below as a demonstration. And that's very cool because it was very easy to add. All you need to add really is this line when you do the configuration of your get.io object. So for me, that's at the beginning here of my setup application function. Just adding this line is going to provide you with the docking support. Next, I also tried to add support for multi-windows. This is another very nice feature from IMGUI. I don't think I have access to that, but you could search on Google and you'll find a different demonstration of this with multi-viewport. The cool thing is you can start dragging your IMGUI windows inside your SDL window, and you can drag them outside of your SDL windows, and that would become a dedicated helper window fully functional, rendering 3D content outside of your actual main window, which is amazing. So I thought, okay, if we could also add that, that would be super cool. Unfortunately, that is not working currently. I have been investigating this a little bit, so I think that's what I mentioned below. Yeah, at first I thought it was something I was missing, because when you try to use multi viewport, you also need an additional handling at the end of your main rendering function. So that's what I have. Let me see. So you have your render frame here, and at the end, when you're done rendering everything concerning your main window, basically you need to check if you have multi-windows, multi-viewport enabled, and in this case you also call those two additional functions. This was also found from no, not from this one, from another one, because for unscripted it doesn't seem to be supported at all, which kind of makes sense in a way, because you would hardly get outside of your browser with unscripted, I think. But in this one, I'm pretty sure we're going to find that. No, not quite. So which one was it? SDL2, maybe? Yeah. Let me find this back. Well, no, it's just I was on the master branch, so there's no multi-viewport support on master, so you need to go on the docking branch, and if you go on docking branch, you will find, for instance, in SDL2, OpenGL3, this configuration where you enable multi-viewport support, and then when it comes to do the rendering, you have this additional section here. Except that obviously when you're rendering with a WebGPU, you don't expect to be manipulating any kind of GL window or GL context. So those two lines I've removed, and this one also was removed. So leaving you with only those two calls. But yeah, unfortunately, this was not really the issue here. The issue is this flag is going to be removed from your config flags anyway, because the inside IMGUI, I don't quite remember where exactly, but yeah, inside you would have a section doing this kind of check. If your backend contains platform as viewport, and if the backend also contains renderer as viewport, then you're going through an additional bunch of checks and so on. But otherwise, you just remove the request to enable multi-viewports. And I was reaching this location because when you're using WebGPU, you do have platform as viewports on Windows list, but you don't have this one. Renderer as viewport is not available for the WebGPU backend currently. So yeah, no luck. We're not going to get this to work easily at least. But anyway, that was not really a big issue anyway. We can live without that. Let's just maybe finish very quickly with a quick demo of what this is looking like. I think I can just do WebGPU IMGUI, and now we have it. So you would see here that I can use my scene, zoom in, zoom out. For now, I only have this simple target camera control system, but later I will add more stuff. And here you have the window that I can drag, resize, and you can start opening some of those entries. What could I show you? For instance, the different widgets are pretty interesting because these are showing the different type of widgets you can build. So simple button, checkbox, different kinds of inputs with plus, minus, drag, sliders that you can drag, and so on. So very, very complete. If you ask me, what could I show you? Plotting, for instance. You can draw any kind of whoa, I didn't even notice the tooltip at the same time. So yeah, you can have color pickers where you can select colors, not here, but that's a big one. This, and it's even resizing when you're resizing the window. So Very cool. And let's maybe try the docking stuff. So let's say we display this additional debug log. You can dock that somewhere. You can add another one like the style editor, and you could put that at the complete bottom or on the second tab or at the bottom of this right tab. So sliders are working great, and I really like this. For instance, you can dynamically change the rounding effect on your different elements. So you see here, if you look at the border here, when you change the rounding, it's going to adapt dynamically. And even for the slider itself, I think it's this one, if you drag it, you see it's becoming either a square or some kind of rounded rectangle. So yeah, amazing. I'm going to do very cool stuff with this interface, and it's working just fine. And yeah, when you see when I'm dragging this, it's not interacting with the scene because it knows that I'm currently dragging the GUI, so the mouse events are not processed by the scene itself. But then the moment I go outside of the GUI, I can start interacting with the scene again. And yeah, I think this is it. Again, pretty long recording as usual. Sorry about that. But yeah, I think we have covered very interesting stuff here. And next step would be now to try to use this new library, a new GUI, to actually build some minimal tests to try to make things a bit more dynamic and interactive in the engine for my different experiments. So that will be for next day, another time. And yeah, meanwhile, happy coding on your side. And thank you very much for looking at this recording, and see you another time, hopefully. Bye bye. Have a nice day. Bye.